Reclamation. Today we have Eric Cavazza. He has 41 years of experience in the field of abandoned mine reclamation, and he is currently the VP of Legacy Coal Restoration with Tetra. So please welcome Eric.
Thank you, Christy. Can everybody hear me okay? All right, I'm going to talk to you today about the Little Conemaugh Mine Drainage Treatment Plant project that we are working on for the Foundation for Pennsylvania Watersheds. It is being funded by the Pennsylvania DEP through a grant to the Foundation for PA Watersheds, and ultimately, when this project is completed and constructed, I believe the plant will be owned and operated by Pennsylvania DEP, the Bureau of Abandoned Mine Reclamation. So what I'm going to talk about, that thing did wrap around, it's covering it up. I'm going to talk a little bit about where the project is and provide background on it. Some other projects that have been completed in the Little Conemaugh watershed. I'll talk about the mining history, the mines involved, and the discharges that we'll be addressing with the project, what the goals and objectives of the project are, the design criteria that we are using to design the plant. I'll go into the current treatment plant layout. We're at the 35% design level. Some of the challenges and the schedule and the estimated cost, and then I'll talk about the stakeholders and partners. So, where is the project? It is near Portage, Pennsylvania. You see where Pittsburgh and State College is, but it's in Cambria County, kind of between Ebensburg and Johnstown for some of the bigger towns in Cambria County. The watershed, as you can see or read on this slide, it's 188 square miles. It's 29 miles long from the headwaters down to where it combines with the Stony Creek in downtown Johnstown to form the Conemaugh River. Eventually it flows through Indiana County and dumps into the Allegheny River at Salzburg. Well, I guess into the Kiski River, eventually into the Allegheny River. So. A little bit of history. There was a group in Cambria County, they're still around, the Stony Creek Conemaugh River Improvement Project. They did an assessment in 1995 on evaluating water quality issues in the Little Conemaugh, and they put together a white paper after that and identified 7 large discharges that were contributing 80 to 90% of the pollution in the watershed. And they affectionately called them the Super 7. And they pushed for a long time to try to get any or all of them addressed to eventually restore water quality in Little Conemaugh. I see all the slides have the heading wrapping. So these are the Super 7 discharges. And just there's 3 of them that are going to be addressed with the Little Conemaugh project, and they're the most furthest upstream in the headwater area of the watershed. And I'll talk a lot more about this as I go through this. The Hughes borehole discharge, the Sonman discharge, and the Miller Shaft discharge. And then you see some of the other ones that are further down in the watershed, and you see where Johnstown is there as well. So the Little Conemaugh has a tough historic record of impacts from mining, and of course Johnstown is famous or infamous for a couple of major flood events, and the Corps of Engineers came in and built those flood walls, but you can see in the picture that the river itself is significantly impacted with iron and other contaminants from abandoned mining operations. As I mentioned, there has been a lot of other work initiated in this watershed to try to restore the entire watershed. And I'm just going to talk briefly about those, but mining company, Rosebud Mining, built an AMD treatment plant at St. Michael, which addressed one of the Super 7 discharges. And then there's 2 pretty large refuse piles One was addressed by Rosebud Mining through a contract with DEP, and the other was addressed by Robindale Energy through also through a contract. And if you saw Jim Pinero's presentation yesterday, that Steinman project was featured in his presentation. So here's a couple of photos, an air photo and a ground photo that shows the Rosebud St. Michael AMD treatment plant. It was put in place to deal with the St. Michael discharge and pull a mine pull down so that Rosebud could access additional coal reserves. There was an agreement reached between Rosebud and the department that will have them turn over this plant to the DEP for continued operation once the mining ends. And they also put money into a trust fund to pay for future O&M. It's my understanding that they gave the department some notice that the turnover is going to occur fairly soon. Am I right about that, John or Joe? Like in the next 6 months? Arnfeld, coal refuse pile, pretty big coal refuse pile that I don't remember the percentage, but a fairly large percentage of Arnfeld Borough consisted of this very large coal refuse pile. It was burning and also contributing sediment and AMD to the little Conemaugh. It was eventually picked up and moved to a abandoned surface mine operation. You can kind of see down in the lower right, the abandoned surface mine has the yellow box around it. The red box was the Arnfeld pile. And the blue line or box is the transport route for the material, but it was amended with alkaline material and used to backfill that large surface mine pit to get it away from the houses in Arnfeld and also to stabilize it so it wasn't contributing any more pollution. Here's a couple of pictures of it with some of the details. You can see that before picture, which was from 1956, and a more recent one with it completed and the hillside green now. I mentioned the Steinman coal refuse pile. It was located along Little Conemaugh on the path of the flood rail trail. Again, another refuse pile. It was removed, and part of it was used as fuel by Robindale at one of their cogen facilities, and then reclaimed. And you can see the trail on the right side, in the upper right, was extended across the reclaimed area. So again, removing another pollution source from the watershed. Some of the mining history here. Cambria County has a pretty significant coal mining history. And you can see that actually began in 1856. John did a presentation on the Blacklick, had a lot of history of the mining there in the Vintondale area. But Johnstown, which is a steel town, has a pretty extensive mining history as well. By 1885, there were nearly 24 mining operations. And toward the end of the 1800s, some other companies began operating in the county, one of which they're highlighted in blue is the C.A. Hughes and Company, started in 1880, and the Sonman Shaft Coal Company in 1883. And then you see by 1901, there were 130 significant mines in the county. And on the right's a few photos of some of those operations. So for this project, there are 4 mines and 3 major discharges. There's the Sonman Slope Mine, which is an upper Freeport coal mine. The C.A. Hughes Mine, which is a lower Katanning or B seam mine. And for those not familiar with the geology, over on the lower right, you can see that the younger or higher in elevation seams is E, and they go downward toward A. So B is an older and deeper coal seam. And then the C prime there, the Portage 2 and 4 mine, is in between those in terms of geology. And then the Sonman Shaft Mine is underneath the Sonman Slope Mine. So it's also in the Lower Katanning. So I always like to include mining history in these because I think it was John or one of the presentations I saw that says you can't judge the people of the past by today's thinking. These people were trying to feed their family and supply fuel to the country that was needed, so they weren't, I don't think they went in with the intent to destroy the little Conemaugh. These are a couple of the mines, the Simon Shaft and Simon Slope mines. All these photos are from the Portage Area Historical Society. And here's the Miller Shaft mine on the left and C.A. Hughes mine. I'm not sure if this is the mine that we're dealing with. There were several C.A. Hughes mines, and it wasn't clear what this was, but it's one of their mines in the same company. So where are these mines? This is a general overview that shows the C.A. Hughes mine furthest to the north, the Slope mine there in the middle, and then the Portage 2 and 4 mine further to the south. And as I mentioned, the Simon Shaft mine is below the Simon Slope mine. So, you know, these names, all these discharges and mines often have multiple names, but here's just a list of the formal name and the common name. So I'll probably refer to them as the Hughes borehole, the Simon discharges, and the Miller Shaft discharge as I go through this. So Miller Shaft, AMD, in fact, we saw this if you went to Scott May's presentation yesterday. They're going to put one of those mine pool monitoring wells into this mine. It's a mine that doesn't have any current monitoring, but for this project, we are designing the plant to be capable of treating this discharge, but we're not actually plumbing this discharge into the plant. That's going to be done at a later time by Pennsylvania DEP. So you see down at the bottom there in the red box, some of the average quality. It's net acidic, a little under 6 pH, and about 30 parts of iron. And you see the other contaminants in the water. It flows an average of about 1,100 gallons a minute, and some of the other statistics are shown in that box in the upper right. The Hughes borehole, a famous site. If you Google Hughes borehole, you'll probably see videos and all kind of accounts of people that go here to visit this site. But it's an artesian borehole discharge, and over the years, a pretty significant, I think it's about a 3 or 4 acre iron delta has formed where there's not much vegetation, as you can see in that upper photo. And it's right adjacent to the little Conemaugh, so it sees a lot of visitors. Here's information on the quality of this discharge. It's more acidic. You see the pH is about, on average, 3.6. Iron is about 70, and some of the other contaminants are listed there as well. The average flow of it is 944 gallons a minute. You can see it's been up as high as over 2,000. The Simon discharge it was a pressure relief borehole that was drilled into the Simon Slope mine to prevent flooding of basements and other things from the mine pool in Portage. You can see it's also acidic. pH is 4.5 roughly, and again, significant iron. It's a pretty big flow. The average is almost 1,600 gallons a minute, and it's been over 3,000 gallons a minute at times. There's 2 other smaller discharges that end up combined with that big Simon borehole that together are all called the Simon discharges. One was a power borehole, one was a water borehole into the old mine, but they both discharge under artesian pressure. And here you can see the quality of the D11 and D12 or the power and water borehole from Simon. Again, pH under 6, about 28 parts of iron, and slightly net acidic. Those two discharges combined average 820 gallons a minute, and they've been as high as almost 1,500 gallons a minute. So those are the primary discharges that we're assessing to treat at this Little Conemaugh treatment plant. There are some goals for the Little Conemaugh restoration that include Little Conemaugh and other work in the watershed, but basically it's to restore the main stem of the Little Conemaugh and the South Fork of the Little Conemaugh so that they support fish and aquatic life. And then where possible to also restore the tributaries. And that's a pretty typical restoration goal for a lot of AMR stream restoration projects. Some technical objectives of the project were to design the plant so that it could treat the Hughes, Simon, and Miller shaft discharges. As I mentioned, when built as conceived right now, only Hughes and Simon will be initially plumbed to the plant, but the plant will have the capacity to also accept the Miller shaft discharge, and the plan is at some point in the future to route it to the plant as well. Instead of running large pipelines, and I'm going to show you a little bit where these discharges are in relation to each other and where the plant location is proposed to be, instead of running pipelines or pump stations above ground, we're going to convey the Hughes discharge underground through the Simon slope mine to the plant. So part of our technical objective is to design that conveyance system to transfer from one mine to the other. Everything in the plant is redundant, so there's a redundant pumping system, a redundant sludge injection system, and then some of the existing boreholes will be preserved in some way, as you see on the bottom one there. The Hughes borehole will be recased, and some of the boreholes, the power and water borehole at Simon will be sealed, but the big pressure relief borehole will be left open but secured so that it's not a hazard. And I already mentioned this, it will initially treat Simon and Hughes with a future plan to also treat the Miller shaft. And when all those are treated, it will restore or significantly improve 22.5 miles of AMD impacted stream. So some of the design criteria for the plant is that the plant will be designed to operate in the range there you see from 2,000 gallons a minute to 12,000. At 12,000, you can see that's over 17 million gallons per day. So that's a pretty large AMD treatment plant. And the plant has to have the capacity to pass that full 12,000 gallons a minute through. We were given some requirements to maintain the mine pool. So those number 3 there just shows the minimum and maximum elevations. So that we'll be pulling the mine pool down, and then once the plant is operating, it'll operate between those 2 elevations. Where the Hughes borehole is going to be transferred to the Simon mine, we are designing a transfer that will limit the amount of flow from one mine to the other at 2,500 gallons a minute or 3.6 million gallons per day. It will also have the capability of being shut off if for any reason there's a need not to transfer the water from Hughes to Simon. So, and it will be redundant. There'll be actually 2, which I'll show here in a little bit. The effluent criteria for the plant, you can see listed there in the table, pretty typical for the mine drainage treatment plants in PA, but the pH in is 6 to 9. Suspended solids less than 35, aluminum less than 0.5, and iron less than 1 milligram per liter. The basis of design for flow, we're designing for the 12,000 gallons a minute, but I just showed the range of flows there. On average, it would be treating 5,200 gallons a minute. The minimum would be 2,000, and then you see the 75th and 90th percentile. And then the combined influent mine water quality anticipated, because we're transferring one mine pool into another mine pool. So what the resultant discharge will be really isn't known. It can only be kind of estimated. So you see there what we're anticipating the influent mine water quality to be for purposes of design. Location, you can see on this map, I'll point out the yellow things first. Portage Bay is in the south center there. Then the Foundation for PA Watersheds, working with PADEP, did acquire a property north of Portage there, which is the yellow arrow coming in from the northwest corner. And then up in the upper right, you see an easement that was obtained, and that was the area where the transfer from Hughes to Simon will take place. And then you see the main discharges there, the Hughes borehole in the top right, the Simon boreholes in the, I guess, left center, and then the Miller shaft discharges down there at the bottom, just a little right of center. So fairly big geographic area for where these are located. We have been working on the design and meeting regularly with Foundation for PA Watersheds and PADEP. We're at the 35% design level right now. So this is the current plant layout on the site. It's going to be a lime treatment system. It will have decarbonation to get rid of excess CO2 in the mine water. And then mixed tanks where lime and polymer will be added, plus there'll be recirculation of some of the iron solids. 2 150-foot diameter clarifiers, and then effluent from there will go through a constructed wetland or polishing wetland. You also see on that drawing the 3 yellow donuts. Those are vertical turbine pumps that are in a set of mains or sub-mains in the Sonman slope mine. Here's the process flow diagram. Probably easier if I move out. But here's the vertical turbine pumps down boreholes, pulling the water out of the mine. From there, it's going to go into a decarbonation tank, which are maelstrom oxidizers to get rid of excess CO2. From there, it goes into reaction tanks where lime comes in, polymer comes in, iron gets recirculated and comes in. And from there, once all that mixing occurs, the water will go into the clarifiers. The underflow from the clarifiers will go to underground disposal, and the supernatant or clear water will go through the engineered wetland and out to Little Conemaugh, which is a pretty standard AMD treatment plant configuration for acidic discharges in PA. This one kind of just shows where those 3 extraction wells are relative to the mine workings. They were on that plan sheet, but you see they're in what was an old coal haulage way in the mine, and we're anticipating that that was probably well supported and probably will still be standing in a good location to extract water. Sludge injection. There is a proposed injection hole that would go into the lower mine, the Sonman Shaft mine, on the property itself, which you see there with the red circle. That's kind of a long-range plan for DEP BAMR for sludge disposal, but they're also proposing to put 2 sludge disposal holes. They weren't in the original project, but they are now, into the Sonman slope mine, down slope of where the mine pool will be drawn down to. And on this figure, you can kind of see where the plant is, which is kind of the black box, and then the 2 sludge disposal holes that are in the Sonman slope mine as proposed now. And PADEP and FPW are working on getting easements for the pipeline corridors to run to those locations. Some challenges. You can't really see my headings on these slides, they're all undercut, but The parcel was acquired for the treatment plant, actually contains over 16 acres of jurisdictional wetlands. And you can see also some streams or watercourses on the property. So as currently proposed, the plant will result in permanent impact to over 12 acres of wetland and over 2,100 linear feet of watercourse or stream. So we've been meeting with the Corps of Engineers and also with the PA/DEP Southwest region to start the process of figuring out how to get that authorized and what kind of mitigation is required. So here's just a couple photos. You can see the wetland in the two photos on the left, and we also have a significant overhead power line running through the middle of that parcel that we have to work around as well. We've talked about the interconnection between the Hughes mine and the Sonman Slope mine a few times. This kind of shows the location of the easement. There is outlines on there, although they're hard to see in red and green, that kind of show how the Sonman Slope mine overlays, is above and overlaps the Hughes mine, and I'll show a better view of that. That road that runs through the middle is Sportsman's Road, for anybody familiar with the geography there. So here you can see the mine workings. The green is the Sonman Slope mine, the red is the Hughes mine, and they do overlap, so we will be putting in boreholes and plumbing to allow the water to be conveyed by artesian pressure from Hughes to Sonman. And that sounds like if there's artesian pressure, it'd be easy. But I'll show you on this drawing, of note is the Hughes mine is in a lower coal seam than the Sonman Slope mine. This is the elevation of the Sonman Slope mine. This is the elevation of the Hughes mine. It's 200 feet below, but yet we're going to transfer by artesian pressure from this mine into this mine. And somebody might say, well, how are you going to do that? If you can see on here, these are structure contours of the coal seam, the lower Katanning. This mine is flooded up almost to the highest elevation in the mine. So the elevation of the water is significantly higher than the elevation of this higher coal seam, the Sonman Slope mine. So a lot of hydraulic calculations have been done and been determined that should be able to make it a transfer from one to the other by artesian pressure. And this is just a preliminary layout of the redundant transfer, one on each side of Sportsman Road, which would allow the water to come up from Hughes and then go back down into Sonman Slope. And that would occur after the mine pool at Sonman Slope has been pulled down and the plant's been operating for a while. Another challenge is that there was a coal preparation plant in Portage that operated for a long time. They disposed of their fine coal refuse or slurry into the Sonman Slope mine, and occasionally some of it discharges out of the Hughes borehole, and you can see one of those events here. So all the componentry of the plant has to be capable of passing this slurry through without damaging pumps and other equipment in the plant. So current project status, you can see well, actually, the contract was awarded back in January of this year, I believe. And we began work, and then once the president took over and started issuing executive orders, there was some uncertainty of the funding. So I think we were shut down for 33 days, and then we resumed again probably in April. I think I have another slide that shows that. But anyway, we did a 5% design submittal in April. Got it approved, did a 10% design in May, got approval for that in July, and we recently, just a few weeks ago or a month ago, submitted the 35% design, and we got comments at the end of September. So what we're doing now is what's shown in blue here. We're working to address all the comments received. We're working to finalize the geotechnical evaluation at the site, we're working to finalize the permitting coordination with not only just the Corps of Engineers and the region, but the county for the erosion and sedimentation control and stormwater management stuff. And then the PADEP is working to get easements for those 2 additional sludge disposal locations. And we've been providing the drawings for that. So that work is progressing. DEP asked, I guess through FPW, for us to slow down a little bit. This project had a very aggressive schedule. But until some of the permitting issues are better identified or we have a better path forward, we're not going full bore into the 65% design at this time. We did do a class 5 cost estimate with the 35% design, and you can see the cost is based on quotes and other experience with similar projects, and the capital cost is estimated at a little over $43 million. We did also a preliminary estimate of the annual O&M cost. Our estimate was probably had a little too much contingency in it, but through some discussions with ASM and PADEP, would think it'll be in the $750,000 to $1.5 million. But that'll be refined as we go through the process. And then the calendar I mentioned, this thing has a lot more detail on it. But originally we had a schedule with FPW to have the final design done around June 1st of next year. So from inception to completion, this is a pretty fast design and permitting. I still think if the Corps and the DEP are agreeable to whatever mitigation is proposed and the analysis that's done for the wetland impacts, it's still possible to get close to this. But we'll have to see. We'll know here in the next couple of months whether that's doable or not. But you can the stuff in red is actual, and the stuff in black was what was in the original schedule. So a lot of partners in the Little Conemaugh, Pennsylvania DEP, Foundation for PA Watersheds, obviously, SCRIP, Robindale Energy has done some they probably removed more refuse piles than just Steinman in the watershed, I'm guessing. But and I know there's at least one more in Portage that's on the horizon that will help with this project as well near the Miller Shaft. Cambria Conservation District, Whipcammer, OSM, Rosebud, and Conemaugh Valley Conservancy, and I probably missed one or two as well. But a lot of interest in this project. It's been on the radar for a long time. It's been worked on, and we're excited to be working on it and look forward to getting it done and getting it built. So that's my overview of the project as it stands now, and if anybody has any questions, I'd be happy to try to answer them. Jim?
Back to your original slide with the 2-7.
Yeah.
With St. Michael already being done, and if this is completed, what amount of that loop loading will be removed?
I don't know the exact percentage. I know there's still a long-range plan to deal with the sulfur run borehole, I believe, and then I think the thought is with this plant, with Miller Shaft added and sulfur run perhaps routed to the Rosebud St. Michael plant, it may be enough to deal with the major pollution in the watershed. Am I accurate, John?
Yeah. The Steinman discharge is gone. Steinman got pulled in by Rosebud's pumping in St. Michael.
Okay.
So I had to give it was a pretty good estimate. When Little Conemaugh comes on, we will have about 65% of the way. We still have Beaverdale, Sulphur Creek, Warhol. The Logan Shaft is still up there, but those are going to kind of be the three that are left, and they're coincidentally kind of all in the south one. So,
The second question, when you said that's on the prep mine slurry, is that going into the Sonman mine or the?
Sonman mine.
So when it discharges, it comes out of the huge borehole?
No, it comes out of the Sonman, the big Sonman borehole, the big 18-inch borehole. Not, I mean, they may be somewhat interconnected through fractures, but there's no direct anywhere documented connection between the two mines.
So when you try to connect them, you're gonna drill a borehole in,
Drill hole into the feed, drill pillar and feed, and then back up overland a short distance and then straight back down into the feed.
Correct. Two locations, redundant.
so we'll go overland for a bit.
Yeah, not really far.
Probably 100 feet or less, something like that. Yes, sir. Or they got two here.
Oh, I was just going back to the timeline slide. I know it's up in the air with timing, but once, if you said the June 1st was the hoped for complete design, and then the numbers got really small. So I wonder like after that, or I know it's a lot up in the air, but.
Well, I'm still optimistic that June 1st is possible. The Corps of Engineers, when we met with them, said if our application addresses, and they gave us a whole laundry list of things they wanted, and we talked through a lot, and there's been some interaction back. They said they would process that and approve it in 120 days. So I think if we get to an agreement and we have the permit application developed, I'm hopeful FPW and PIDP will say, you know, it's more or less just crossing all the I's, or crossing all the T's, dotting all the I's, and we'll get right back at it and move into that 65% design. I think we've met weekly since this started with DEP and FPW, which I think was very good for this project because I don't anticipate a lot of comments on things from this point forward. It's pretty much, we've agreed this is what needs done. So it's all just going to be the hard design work and putting the plans and specifications and details together for all that stuff from this point forward. So.
Like from June 1st to the date of construction?
Well, the design would go to FPW, which would go to DEP. DEP is going to bid it out. And, you know, from my time there, my thought is that it's probably a minimum of 4 months, more likely 6 months or even longer if there's any slowdown. But potentially it could be bid out by the end of 2026 if everything went well and start construction in 2027. Carl.
What are some of the factors that went into the decision to put the treatment plant where it is? From an engineering constructability standpoint, or?
It has to do some with where the mines are located and what is available there to get the discharges to the plant and get the vertical turbine pumps in, and also sludge disposal. Also, I know DEP evaluated a number of properties in addition to the one that's currently the target, and you know, they had to have cooperative landowners. So there were several other properties looked at, and there were issues with some of those, and probably could do another presentation on property selection for this project by itself. But it is a good location relative to where the mine workings are and what options we have to get the water to the plant and also handle sludge. Yes, sir.
So the Miller mine will be connected underground also, ultimately?
I think it's possible, but I don't think any final decision. And again, I could let DEP maybe answer that. It could be overland, or it could be potentially routed underground and brought to the plant as well.
That's the issue.
Yeah.
We're probably gonna attempt direction one, but the long story here is the E mine that's on the slope entry is heavily retreat mine in that section of town. We're unsure of how well it's going to transmit that much water through, but I think if we break in the right spot, I think it will disperse and push the water through the gob or around the edge through the fractures. So we won't know it until we try it. It'll be a very costly experiment, but versus trying to go straight through the middle of town with another utility pipeline, it's probably worth the estimate.
I mentioned earlier, there's no monitoring well in the Miller shaft mine, so we don't know how much pool is in that mine or if it's free draining. And Scott May, when he did his presentation yesterday, indicated that's on their list to put a a monitoring well in there that will have continuous elevation recording and other data. So that'll probably help them make the decision of how best to move that. It'll give them more data. Yes.
Mr. Quigley had said that once this is done, it'll be 22.5 miles of stream improved. Is that after the Miller is also part of that, or is that?
Yes, I believe the report that was done includes Miller Shaft. So there's 15 miles from the plant to the point in Johnstown, and then there's about 7.5 miles, I think, of the main stem of Conemaugh also that would be improved because of the removal of the pollution.
Yeah, there's only a couple miles of Trout Run, which is the tributary that the Miller Shaft turns to. So it's actually kind of a short distance through the portage. But it is also the stream that runs right through town and is the most visible. So we want to get it, don't want to leave it behind.
Right, well, unfortunately, we're out of time for more questions. The next presentation will start at 11:15. Just as a reminder, please fill out your surveys to help us plan for future events. Thank you again, Eric.
Oh.
And,